Hello everyone, and welcome to our Getting Started with Arduino and C++ programming class. Today we're going to be studying basic variables and control structures. Alright, what is a variable? A variable is just a name given to a location in memory. Memory can only store numbers, but numbers can be used to represent physical objects or symbols such as letters. Today we're going to create a bunch of different types of variables and experiment with their application. Alright, let's try out a simple example program. Samples. Let's start out with the bare minimum sketch. This contains just what we need to get started. Setup routine that runs as soon as the Arduino boots, and the loop routine that runs repeatedly as the Arduino operates. And we're going to give it a name. We're going to call it ABC. So I've saved it, and we're going to create our first variable. There we go. We're going to create an integer called count. Count is just a name. It could be called anything that's not a reserved word. Integer means this variable contains a number between 0 and 65,535. That's not always the case. We'll talk about things like modifiers and such later. Now, the first thing I'm going to do is set count equal to 0. So when the Arduino boots, count will start at 0. And then every time loop is called, I'm going to set count equal to count plus 1. So it will count up. And then all we have to do is print that out. So let's pop open our examples, basic. Digital read serial. We'll copy and paste our serial setup code. Configure the serial to operate at 9600. And go ahead and grab the print line code. Alright, count. Let's go ahead and upload it to the Arduino. And when we run it, we see that basically it is now counting. And it will just continue to count. It'll count until it rolls over. When it hits its limit, it'll roll over to 0. That's interesting, but we can do better. Okay, let's make a change. Count is what's called a global variable. That is, it's a variable that can be seen by all functions in the program. So any function anywhere in your program can see that variable, edit it, change its value, read its value, whatever. But let's make count a local variable. We'll make a count a local variable in the function loop. Alright, here we go. Now count exists in the function loop, but it doesn't exist in the function setup. So if I try to upload it now, you'll see that setup doesn't know what count is. It can't work with it. It can't assign a value to it. So we'll have to take that out and put it down here. So only the loop function can work with count now. So when the loop function is called, it'll create this variable called count. It'll assign it a value 0, then it'll add 1 to it, and then it'll print that value out. Let's see that happen. Alright, here you go. Now, why is the value not incrementing anymore? Well, the reason the value is not continuing to increment is because a local variable only exists as long as the function exists. So the function is invoked, it sets count equal to 0, it adds 1 to count, it prints it out, and then when the function ends right here, the count variable is destroyed. And next time loop gets called, it starts all over again with count equal to 0. Alright, time to change this up a little bit. Let's introduce our first control structure. We're going to introduce a control structure called while. While is a loop structure. Basically, it loops between these two brackets. So when the while is entered, everything inside the brackets will run over and over and over again, just like they do inside the loop function. This one parameter that's passed to while basically tells while when to loop, and while will continue to loop as long as that parameter is not 0. Now, because I'm setting the parameter to 1 and there's no provision within the program to change that parameter, this while loop will never stop. If I go ahead and execute this now, you'll see that we've got our counting functionality back. But I don't want the program to count. I want the program to sing its ABCs. So let's go ahead and explore another variable type called character. Characters are designed to store character data. They can contain a number between 0 and 255. Let's see what that means. Our print line statement needs to be changed as well, because decimal is designed to print integers, so we need to use byte to print out characters. Let's upload that and see how it behaves. Now that's going pretty fast, so let's go ahead and slow it down. Okay, you can see here that the system is cycling through various symbols. The character data can represent many different kinds of symbols, and generally they are only interested in your standard numbers, letters, and punctuation marks. But the exact symbols that can be displayed are referred to as ASCII. You can look up an ASCII table in Google pretty easy. Just type in ASCII table and several will pop up. And you can see the table will basically have a mapping between numbers and symbols. In this case, the number 97 represents a lowercase a. The number 65 represents an uppercase a. Every symbol has a number. Even the symbols 0 through 9 have numbers associated. It's important to keep in mind that the graphic, the image of a 0, is something that the microcontroller has no concept of. All it knows is numbers. It doesn't know how to draw a picture of a 0 or a picture of a 3. And that's what we're doing here, is we're saying that we're going to store the symbol 0, not the value 0. Obviously, we don't want this piece of code to cycle through all those symbols. So let's go ahead and initialize count to the letter A. This is going to start count at the letter A as opposed to starting count at 0, which if you look at your ASCII table, you'll see 0 is null and 1 is start of heading, and these are basically called control characters, and these control characters do many odd things on many odd platforms, and we're not interested in any of them right now, so we're just going to tell our program to start at the letter A. Now, when the program hits Z, we need to start it back over at A. So let's go ahead and detect that condition. If count equals Z, then count equals A. This is what's called an if statement. An if statement checks to see if a certain value is true, and if it is true, then it executes a section of code. In this case, if count is equal to Z, it's going to set count equal to A. Now you'll notice that I'm using two different kinds of equal signs here. The double equal is a comparison operator. Does count equal Z? Is the current value of count Z? A single equals is an assignment operator. That says set count equal to the value A. Now obviously if we get these mixed up, bad things will happen. If this was a single equals, then every time this checked the if statement, count would be set to Z. And if this was a double equals, then this line would do nothing. So let's go ahead and make sure they're set right. And let's see the output of our program. Now you can see here the program is working great, but it started at B. That's because we set count to equal to A, and at the beginning of the loop we add 1. So let's fix that. In addition, I want to wait a little bit at the end of the loop. Let's change how we're doing our delays. Alright, so we've changed our function around a little bit. Now, if count is equal to A, we're waiting 500 milliseconds. This will give us time to realize that we've stopped counting. Otherwise, the delay is only going to be 100 milliseconds. This is called an else clause. In an if statement, if this value is true, the first part is executed. If this value is not true, then the else clause is executed. Let's go ahead and see this work. As you can see here, we are still missing the letter A. That's because we're assigning count equal to A here, and doing our increment right there. There's a couple ways we can solve that. We can either set count equal to a minus 1, so that when this increments this, it increments it up to a. Or we can make sure that we do our check before we do our print line. Okay, let's see how this one looks. And we see that looks like we have introduced the opposite bug. Now we don't get a z. Well, again, if count is equal to z, we're setting it to a before we do the print. So what are we going to do? Let's go ahead and change this to say if count is greater than z. This means if count has gone past z, then go ahead and change it to a. Let's see what this looks like now. Alright, we're starting at a, that's good. Okay, we printed z, that's good. What you've just seen is commonly referred to as an off by 1 error. It's a very common sort of programming error, very common sort of logic error you'll run into and have to fix all the time. Alright, let's reorganize this whole program again. Let's get rid of all this. And so now we're starting with a count initialized to a. We're going to print it out, and then we're going to go count equals count plus 1. Now, if count is greater than z, we want to exit the loop. Well, how are we going to do that? Let's create a new variable. Bool looping equals 1. Now, Boolean variables can only hold the numbers 0 and 1. They are either on or they're off. An important thing to keep in mind is that even though Boolean variables can only hold 0 through 1, they do use a whole byte of storage space. So this Boolean uses the same amount of storage as a character. So we're going to change while to while looping. So while looping is true. Now in C, something is true if it doesn't equal 0. 0 is false. Everything else is true. So as long as looping does not equal 0, this loop will continue. And when we want the while loop to stop, we just go looping equals 0. So now looping is false. And then let's go serial print line. Now I know my ABCs. Won't you come and play with me? While 1 delay. Let's see what this looks like. There we go. We sang our alphabet. Let's just do a quick review of this piece of code. So the Arduino starts and it boots up, and first it calls setup, and we configure our serial port to operate at 9600 baud. Then the Arduino calls loop. We create a variable called count, and we set it to a. We also create a variable called looping, and we set it to 1, or true. While looping is true, this block of code executes over and over again. And what do? We print out the value of the count variable. We print it out as a byte interpreted as a character. Then we increase count by 1. Then we check to see if count has exceeded z. And if count has exceeded z, we set looping equal to false so that the loop will break. Next, we print out our little sing-song finish. And then this little piece of code here just goes and delays for 1 second over and over again ad infinitum, and so the program basically stops. Well, that's it for today's class. Next week we'll build on these fundamentals and get a little more theoretical, describe a little bit more about what's going on and what all this means.